Welcome, data people. We are Zuma. My name is Matt, and this is the Data for Good podcast. This podcast is brought to you by Zuma. Zuma is a dedicated recruitment company focusing on data positions across Berlin. The Data for Good podcast is for the world of data science, analytics, and engineering, giving you a platform to the thoughts and opinions of data leaders from Berlin and beyond. Today, we are joined by Alex Fedorov, Head of Engineering at Ride Capital. Alex, welcome. How are you?
Thank you, Matt. Thank you. I'm doing well.
Amazing. It's great to have you join us. For those who don't know yourself or aren't aware of Ride Capital, can you give us a quick introduction?
Yes, of course. I'm happy to. So my name is Alex, as you already heard. I am head of engineering at Ride Capital, and I've essentially started almost from the day one as the first employee of the company and built the full engineering discipline here. Additionally, besides that, I've been in the industry for quite a while with almost 15 years of professional experience. And before that, I've been for 9 years in competitive programming, which was a lot of fun.
Nice.
Additionally, for the past 7 years, I've been thinking a lot about software engineering, how to do it better. So I wrote a book about this. You can find me on the internet and see what that is about.
Awesome. So for the listeners who do want to check that out, what should they be searching? What's the name of the book?
The book is called 10x Software Engineering Delivery.
Okay. Well, while we're here, do you want to give us a quick little plug?
That's fine. I mean, it says what it is. It's about how can we get into the world of delivering 10x amounts of business value through software engineering.
Amazing. So yeah, if you're curious, then you'll know what to search, and of course, reach out to Alex as well. So we're going to tap into that wisdom today. Now we're here to talk about closing the skills gap in data with software engineering, but also vice versa. So to start off, what do we mean by this when we're closing the skills gap?
Well, let me start and open this topic. So obviously, when software engineers try to work on anything that's data related, they would approach this from their perspective, from the perspective of building software in sort of a business domain, business logic kind of approach, which usually isn't what you want to have in your data warehouse or in your data pipelines or in analysis. It's not the same shape of data. It's not the same way it looks like. It's some of the principles are not the same. And additionally, there's as well knowledge and skill gap from that. The other perspective is that when experienced data engineers and data analysts work with the data and essentially build software. So data warehouses, what are their software? They have things that they can learn from software engineering as well, how to build more resilient systems that have less regressions, less bugs, and so on.
Okay, so what are the benefits of this?
The benefits of that skill exchange, essentially. Well, the benefits from one side is that software engineers who have been working with data warehouses before and with data engineers, they of course will build systems in the future in a better way that is more adaptable and more have better interface to data warehouses, and which would make the systems more accessible, the data of the systems more available to the business in the long run. On the other hand, when data engineers, data analysts learn from software engineering how to do software engineering better, then the maintenance costs, for example, of the data warehouses will be reduced because it will have less bugs, less regressions. Making changes in data warehousing logic will be easier and faster.
Sounds like a lot of positives. What challenges might there be, or what should we be cautious of when introducing a software developer into a data ecosystem?
Well, what we should be conscious of is if people don't want to collaborate much or learn from each other. So that's definitely a risk, because if somebody, let's say, wants to just do the work and make it done and make it work without collaborating too much with another discipline, then what will happen is that you will not gain this benefits or will gain only partially, and potentially there will be even damaging factors. For example, if software engineer without any interaction with data engineer, somebody who has such experience, builds a data warehouse, they're probably not going to build it correctly. They're probably going to build very inflexible data warehouse, and then later down the line will need to be either majorly refactored or rebuilt from scratch.
Yeah. So where in the journey do you think it's most valuable to introduce a software engineer into a data ecosystem, or if there is no talent out there that we can find, how do we take that step?
Well, I mean, I'm assuming it's probably not always the case, but most of the times in the organization you would have data engineers, data analysts, and software engineers and product managers, and these kind of two worlds, I think, need to work closer to each other when they build things together. So what do I mean by this? Let's say that some new data point or essentially a new model needs to be created in data warehouse. Of course, the data engineers and analysts can just do that on their own, figure out what is the model looks like from software engineering side, and kind of ingest it and then perform analysis on it after all the transformations that they need to do. Or they can do it together. So instead of doing it asynchronously, they can work together with software engineer or a couple of engineers and perform this task together. When they perform this task together, what happens is that engineers learn about how to deal with data in a better way. And at the same time, they share their knowledge and observations and why they did certain things in certain ways with the data engineers. So there's sort of an exchange of knowledge. And data engineers become a little bit more like software engineers become a little more like data engineers, and they are able to also use these different tools in different contexts. I can give you a very particular example of two very different, very different ways to approach data between software engineering and data engineering. So software engineers have this principle called YAGNI. It means you aren't going to need it. And when applied in software engineering databases, it works quite well because you don't create data points or fields or that you probably not going to need because it's going to be wasted and they need to be maintained and so on. So it's a very helpful in software engineering. However, in data engineering, actually the opposite rule or opposite principle often applies. I don't mean always, but often applies. Different principle called we called it because software engineers here at Ride worked with data engineers, so we kind of try to express these ideas better. We have the word YAGNI, but the word on the other side did not exist, so we invented it. We call it YAGNI-A, which means opposite to you aren't going to need it. It actually says you are going to need it all.
Okay.
So essentially, when you look in data engineering and build in data warehouses, what you end up building very often is not minimal tiny models where you just have what you need right now. You actually go much wider and you include much more data points that you might need at any point in time in the future. Of course, structurally, the data warehouse still needs to be YAGNI, so you don't need to introduce layers that you don't need yet, because that will increase complexity. But in terms of data points, you essentially try to have as many as you can, because they will come and will become useful, and you don't know how yet.
So it sounds like you've had success in merging these two domains.
We now are, and by the way, and just to tell you about the skill kind of interaction is that software engineers now actually, after interacting with data engineering, are thinking now in terms of, is YAGNI applicable here or YAGNI-A applicable here? Just to give you an example, in the past, when we would send some data into third-party system, like for some kind of synchronization purpose, because another team, for example, needed to use the data in that other system, for example, CRM, we would in the past apply YAGNI principle and just send what is today necessary. But then every time, of course, the the users of the CRM system, we needed more data. We would have to implement more and more and more information, which is a lot of going back and forth and reloading the context and so on. Not very effective way to do this, but it kind of works. But now we approach this kind of problem as YAGNIA, even in software engineering, because it actually is more helpful to give more data than less. Of course, there are exceptions like compliance and so on, with some data we cannot synchronize. But besides these, the more data, the better.
So as a manager and overseeing this kind of joining of cultures, I guess, what would you advise someone who's starting that journey or is beginning to consider that, what to keep an eye out for? What lessons did you learn that you wish you knew back then?
Well, I mean, I think that the cross-functional kind of team approach applies here very well. So, like classical cross-functional team, you would just think, oh yeah, I have my product manager, designer, and developers, maybe some QA, maybe different kind of developers, front end, back end. However, I think that it's very useful, if you can, of course, if you have the resources and people, is to have teams include data engineering as well, or data analysts, because then they can contribute to development of the whole features and epics, even in their infancy, in the first stages. They can imagine that if you didn't have to, after the development team has already implemented something, and later you remember, oh, we need to also have this in data warehouse so that we can gain insights from there in our business intelligence systems. Instead, you actually build that in as the features are being developed. I think that this type of cross-functional team approach should include data as well. That's my learning.
What do you think the reluctance has been to include data previously?
Well, I think because it's always treated as a separate team or sometimes even arm of the organization, where you would have, depending on the size of organization, we might have CTO, and then you would have a team of developers or teams of developers, and then there is a separate team for data with the data analysts, data engineers, or analytics engineers. However, I think that approach is probably a little bit flawed, because the closer they work with each other, the more effective they become. At least that's my experience so far. It does require a little bit more of collaborative culture, of course. Like without collaboration, it's not going to be more efficient, so there's no point. However, if you can have a collaborative culture, then there is a sense in doing this. There is probably another interesting point, because there is usually more software engineers and teams that are bigger teams than data teams, is because because of the market, the job market, but also demand. So amount of work that needs to be done by software engineers. There's much more stuff to do, more features to develop, more applications and products to launch, etc. And the amount of data work that needs to be done on top of that, at least initially, right, in initial stages of the organization and products, is not as much as the feature development. So this is also probably why there's some supply and demand factor to this, so that sometimes if you just have maybe 2 data persons in the whole organization, just because that's the amount of work that they need to do, and because of how many of them you can actually find on the market, then it makes sense to put them in a single team just for efficiency's sake, of course. So that's another driving factor. However, maybe that needs to be challenged, because maybe that efficiency gain can be overshadowed by collaborative gains from cross-functional teaming. So maybe if you don't have enough people in data, they can be a kind of like traveling team members, where for a quarter they spend time with one team and another quarter they spend time with another team. So you could do things like that as well.
How motivating, or do you think a lot of people would be interested in that type of work from data, moving from team to team? Do you reckon it would have to be a certain type of person, or is that the evolution of a data specialist? How do you see it?
Well, it depends. I think it is not a special type of person. It's just a type of person. These types already exist, because you have like a really data engineer who wants to build warehouses and build layers of architecture and data processing, maybe do also advanced ML and so on. So they are interested in technology more. And then there is maybe like a data scientist or data analyst who, yes, they can do the technology, but they're actually more interested in business and people and so on, and figuring out how to make that work, how to deliver business value. So obviously the person who is more interested in people will be more interested and more suitable for this cross-team collaboration initiatives. However, my personal belief is that even the person who is more interested in technology still would benefit from exposing themselves more to sort of cross-functional collaboration, because they can learn from it and improve their craft and their skills.
So domain knowledge, how important is this?
Domain knowledge. Well, domain knowledge in what do you mean by domain? I mean specific company business domain, or do you mean domain knowledge of technology, or what are you talking about?
Yeah, so if a data person is getting into various teams and moving across, is that early stage companies that you're gonna have to be a generalist and then they evolve into a domain specialist? Where do you see it?
I see. So obviously it's very similar in startups and also in engineers and other roles. In a company that is smaller, pretty much everybody has to be as somewhat generalist, if not entirely generalist. And then only little special skills are actually required in smaller organizations and startups. And even then, if you're a specialist, you're still sort of expected to have shallow knowledge of other things and interact in other domains. And then as the company grows, you don't have the problem anymore that people need to jump, because if the company is larger, then it can actually afford to have maybe one data engineer or one data analyst per each like feature team or domain specific team. You probably can afford that, actually.
Do you think it will remain that way? Do you think a generalist, if you were to set out your career now, knowing what you know now and having a bit of an idea of the future, would you advise picking a domain and becoming a specialist with the entry level to technologies being easier, or do you think it is still wise to be a generalist and cover as many areas as you can?
I think both work, actually. I'll explain to you how, in what way. The only thing that you can't do, you can be really in the middle. Like you have to, at least in the beginning career, to commit to either be a specialist in one thing and one domain, and then that accelerates your career in that domain and the specialty, of course. And then later you add more other skills and more other domains in your general toolbox and tool set, so you become more versatile, and then you have more choices, and you can contribute at multiple levels. Like you can essentially, and then eventually, you can become either your own entrepreneur or go into management and do other things, because understanding of more than just one specialty is required to do these things. Or there's another way, which you start as a generalist. So you can do a little bit of that, a little bit of this, a little bit of this domain, a little bit of this. So you have this general knowledge, which means that you'll probably be a good communicator as well. Well, that's required, because in order to make use of all this general knowledge of different domains and different specialties and technologies, you would need to work with other people to make things happen. So it's also communication skill is required there. And then you can start your career like this as well, because then you might be a data engineer, data analyst, but also you'll probably be part-time in as a product manager or something like this as well. And essentially making everybody work together, achieve bigger goals, bigger targets of the organization. And that's also very valuable for the career, because then you're more likely to have bigger achievements under your belt in the so to speak in your CV, right? And then after that, once you have all of these generalists, you can also decide to deepen specialty in 1 or 2 or 3 subjects, and also you can decide to focus on one of the business domains. So to give you an example, I've always been a generalist myself as an engineer, then later as a manager. So I can do whatever is necessary to be done, of course. So this is a very nice skill to have because it allows me to go wide and figure stuff out. However, I do have few things that I also specialized on later. In my particular case, I specialized on testing and test-driven development. Besides being, generalist programmer who can do everything, I'm really good at making sure that applications are very well tested.
Yeah.
And also that it's systematically they keep being well tested and don't break. And then later on as well, somewhere around the time when I joined Ride, a little bit later, I realized I really loved financial technology. So I'm also specialized now and will keep that specialty in the domain of financial technology.
Amazing. So to have a use case within data, you've developed yourself as a software developer, as a generalist, and then you end up being asked to build a data infrastructure as a software developer.
Yes.
Tell us about this.
I can tell you a little bit more about this. So, in this case, I didn't do this as a software job. I had this as a head of engineering, of course, but I did this at Ride in particular. I developed a data warehouse. However, I did this with some help. I didn't do this alone, of course. So the way it worked is that we have hired a consultant who has deep knowledge of how to build a data warehouses, and he consulted with us, and he essentially helped us build the first version. We provided business domain knowledge of what we have, what we want, what's this all about, and they provided good technology choices and good initial version 1 structure of how to build this. So, and we had a pilot for one of the business cases. And then later on, already without this consultant, we decided to become much more data-driven company. Well, we had this decision before, but now we started executing this seriously. So I've built a team. And that team was very interesting because that team, in this case, did not have data engineers. It was constructed only from software engineers.
Right.
Because the data engineer, that analyst that we hired still had 2 months before they joined. So we were still waiting for them, but we already wanted to get a head start. And we had a good, blueprint of how to do this with what has been provided to us by the consultant. And we kind of understood the model and we were replicating this. But this is where we, of course, learned some things. That's where we learned Yagni versus Yagnia in the process. This is also where as software engineers in that team, we have started thinking, okay, cool. So this structure makes sense. This architecture makes sense. How do we make sure that this doesn't break? Because, in software engineering, we always are trying to make sure that, okay, we can deliver our changes to production system and go to sleep at night and not worry that something will break, right? So that's an important thing for us. So, and at this point, we struggled a little bit with this because there are no natural tools to do testing and ensuring that the software is bug-free besides, just deploying the new version of your warehouse and seeing that nothing broke. Right? It's a very manual process. So our first iteration of this was essentially just because the whole warehouse it's a DBT warehouse. So it has these layers with queries. So there are reporting queries that get materialized as tables. There are staging queries that get materialized as tables. There are snapshot layer as well. And there is a source layer that gets ingested from the data lake. And we thought, well, if it's all queries through and through that get materialized, what if we wrote queries that would look at the data as was imported by a reporting query, for example, So there's a reporting layer, there's a table with data, and we would have another query, we call it validation query, that would do some analysis on that query to verify that there are no problems in it, like it's as we expect.
Yeah.
So there was like a version 1 of this, and we run it manually. We run this query manually, and it relied on us knowing what data we expect to get. And the interesting thing about this, as you know, every month we had to update these validation queries because they actually were running against real. They were having expectations of production data, like for example, number of new customers, right? They expected that this month and this month and this month we should have this, and then it's split by every product that we have. And once new months appears, we should expect another entry, but obviously we had to update the validation query. That was sort of manual process, and it essentially it helped us with immediate feedback cycle, whether we are making a mistake or we're doing the right thing during the development, but didn't help us later in production by saying, is this still correct or not? Because whenever we want to test this question, we would have to update that validation first, query manually, and then run it manually. So it's not quite to the same level as we have in software engineering, where we have continuous integration process where everything just gets tested automatically, and we either have a green sign or red sign, whether it works or doesn't. Like it's binary. There's no manual involvement. You just know. So the way that we will evolve this later is by studying out the source layer. So we actually had 2 jobs in our DBT system. One is a deployment job, which actually deploys the real warehouse using real data. And there's another job which essentially substitutes the source layer. Instead of real source layer with real data, it provides like a fake source with fake data that is static, doesn't change. And then it runs the whole warehouse on top of this. And then we just verify that the reporting queries and entity queries produce the right results. And that is now automated and automatable, and it really shows you either green or red, either it works or doesn't. And now every time we make a change to our data warehouse, these tests run in a separate job, and we know if we broke something or not. That we haven't supposed to be changed, and this really allows us to as well sleep well at night.
So many things that the data can learn from software best practices. Is there any others that are evident that are able to be implemented that are scalable, sustainable in a data environment?
I think these are the 2 main ones. So Yagnia, which software learns from data, and then testability, which data learned from software. You know, if we talk about this 6 months from now, maybe I'll have a couple more for you, but this is so far our major learnings.
Amazing. I mean, we could carry on for much longer talking about this. I'm conscious of time, so let's finish with one final question. So, best practices, high quality. What's the number one thing that we should be considering as data professionals that we've learned from software developers moving forward?
That's a good question. So I think it is probably quality that would be the one that I would choose. Because as in software engineering industry, we have, we put a lot of focus on quality and naming of things, on consistency as well. By quality, I mean not so much quality of the data, because quality of the data obviously should be, because if data is low quality, then it's not very valuable. So that's of course is a ultimate requirement. However, what I'm talking about is the quality of the code and the queries. How easy are they to understand and read and work with? Because what often happens is that you need to return to some query or some code that in one of your data layers from 3 months ago or 6 months ago, and it's very difficult to understand because it might be very complex, or it might use unobvious names like single letter names instead of proper full names like words. So I think that level of readability and understandability is important. And of course, then the testability as well, because it's really good feeling when you make changes and you can tell whether it works or not in a couple of seconds.
Yeah.
Instead of having to worry that you're missing something, that it kind of works, but you're not 100% sure it will work entirely.
Absolutely. So much to learn. I mean, data's been around a long time. Software best practices probably a little bit longer, and there's so much more to bring into the workflow. But unfortunately, that is all. Have you got a final point you want to make there?
I want to add something on this. So I think, yes, we have to learn from data. Data can learn from us. However, we need to remember that we're all, in the end, programmers. We are one and the same, and we should remember our roots and keep learning from each other and keep innovating and finding better ways to do things.
Absolutely. Very well articulated, and a great point to finish on, because unfortunately that is all we have time for today. But thank you very much for your time and your rich insights, Alex.
Thank you, Matt.
And to listeners, always don't forget to like and share so we can reach as many people as possible. Invaluable insights from Alex today, but it is bye from us. Thanks once again, Alex.
Thank you, Matt. Bye-bye.
Ciao for now.